Good morning. Good morning, buongiorno, dobry den, buenos dias, bon dia. I don't know, we have so many nationalities in this conference that usually that's how I open any moderation sessions. Hi, good morning. My name is Oscar Cabrices. I'll be moderating today's session. On behalf of MassTech, thank you very much for attending this breakfast seminar. Welcome to all the speakers and everybody. Hope everybody had a good trip up here to Baltimore. I know I did. It was pretty eventful. So please don't forget to visit MassTech's booth on it's number 323. And we have a lot of good collaborators, like a lot of us are. Folks from Accent, they make their portable HPLC sun chrome for doing the MALDI sprayer, and MSI Solutions and Spectra Swiss who are our imaging partners. So with that, I think we're going to have really good talks, not only today, but tomorrow, especially on the AP-MALDI platform. And to begin today, this morning, I'd like to welcome MassTech CEO, Venkat Panchagula, good friend of mine. We invited him. Come on. Just give him a round of applause. And he has some really good words to say to you.
From MassTech and all our partners, collaborators, everybody has put in a lot of efforts over the last few weeks. Thank you, every one of them. But I'm here to just make a very small announcement. Since we are on a home turf, and we, of course, our tools support great science, and we're grateful to all the users. But MassTech also has been doing some fantastic science. And the first speaker today is Vladimir, but I just wanted to take a moment to celebrate and honor all the great science that actually MassTech scientists have been doing for the last 2+ decades under the leadership of Vladimir Doroshenko. So today's session is in honor of Vladimir, who has published a lot, patented a lot of stuff. He's a great scientist. He loves being in the lab all the time. And so Vladimir, come on over.
Thank you for. So my title contains what historical notes. Historical notes typically means either company is very old or the speaker is old. Probably both are. Historical view means a little bit personal view, and for this reason it may be subjective, and I apologize in advance if my talk adds some spice to your meal. So enjoy your breakfast and go forward. As you know, ion trapping using radio frequency electric field is a pretty old technique. It is more than 70 years old already. Diagram of its development is at the left. It's from George Stafford work. And it was, development was pretty smooth without any extraordinary events for 30 years since the invention of this technique by Wolfgang Paul in 1953. And everything changed at the middle of 80s after introduction by Finnegan Mott by first quadruple ion trap based mass analyzer called ITD 700. 7 years after that event, the Nobel Prize was awarded to Wolfgang Paul. We came to this field about the same time, and we were very excited by that event. It means that it indicated that this is very hot research field for us. But for everybody who was involved in this development, it was pretty clear that mass selective ejection, which was patented by Finnegan, is pretty strange name for this development, because in general you cannot imagine that for 30 years on prior development, nobody tried scanning ions out of stability diagram. But that's why we were in this field, just to study more, study the reasons why we got this very good performance of ion trap. So here, this is my personal view. Major research group involved in studies in this field. Three first participants actually were all of them were from Graham Cook's Purdue University. Later, then formed independent groups, and I added Bob Cutter at Johns Hopkins lab, and hundreds of papers actually were published on in this field for instrumentation of this technique. First three groups had special relations with Thorma Finnegan at that time. What it means, privileged relations mean that they got special research grade ion trap mass spectrometer. It's called ASMS. And for this reason, they had a big advantage in development. This technique came with all instrumentation, electronics, software, script, so you can do whatever you want with this hardware. Bob Cutter has special relations with Shimadzu. We didn't have anything like NTMS, but that was not actually a big problem because we had ITD 800, which had trap electrodes, ref generator, so you can add your control electronics, write software, and run actually the same experiments. Taking this opportunity, I actually would like to mention one more research group, which was important for me. This is a group of Russian scientists which came in 90s in US and worked in different, mostly universities. The reason was very simple, because Russia had very strong mass spec schools at that time, and I listed the most prominent figures in Russia at that time. Viktor Talroze, inventor of chemical ionization, is considered to be father of Russian mass spectrometry. Boris Mambirin, inventor of ion mirror, currently more known as a reflectron, and it is used virtually in every time-of-flight mass spectrometer now. Alexander Dodonov, inventor of orthogonal reflectron time-of-flight mass spectrometer. Again, any big commercial company uses this instrument as a for commercial use. Lydia Gall, Lydia lab was the first where electrospray ions actually was generated. In addition, she started also working with electrostatic trapping device for different reasons, including focusing and trapping, which is currently called Ortotov, and Alexander Makarin cites Lydia Gall original work all the time. Eugene Nikolaev is known for his pioneered work in FT-ICR-MS, meaning developing this technique to a perfect state. Ernst Sheretov group was the strongest group in Ryazan Radiotechnical Institute. They are mostly busy with quadruple ion trapping technique. So you can imagine that students and postdocs, they came here, we communicated, meeting at the ASMS every time, exchange ideas, discussions. And so this helped very much in development of mass spectrometry in many areas, not only quadruple ion trap. Just one example of this. In 1992, Thermo Finnegan finally announced, because everyone suspected at that time, and there was a lot of publication indicated about this, that they didn't use actually pure quadrupole geometry of the trap, they stretched it. And actually that stretching, they knew about this, that responsible for that very good performance. But actual mechanism of the stretching on resolution, for example, was not known exactly. So a few years later, young, not known Russian scientist Alexander Makarov, he published a paper where he analytically explained all mechanism of improving substantially resolution in quadrupole ion trap when a weak octopole field is added to the main quadrupole field. And so this figure at the bottom explains this mechanism. So for standard harmonic oscillator, oscillator, the resonance curve is like symmetrical bell curve. But if you add octopole field, that resonance curve is bent to side. And then imagine when you scan frequency of your ions, whatever means you're using, you go along this curve, and when you reach point D and move resonance frequency further, for ions there is no way to stay on this curve, it jumps immediately to point A. And that's what is responsible for high resolution observed in all commercial traps. I personally observed 50,000 resolution on the Finnegan ion trap. But that resolution can be obtained only in one scan. Because of instability of electronics, next scan induces shifts, and so you cannot observe it in real spectra. But mechanism is truly there. So switching back to MassTech development. So we worked on basics of ion trap all the time, but as for commercial efforts, we started actually with time-of-flight mass spectrometer. That was N-cap reflectron time-of-flight mass analyzer developed in Bob Cutter's lab in Johns Hopkins University. In general, feature of this, we try to use UV and infrared MALDI inside. But the biggest lesson we learned from this, that the most difficult part in designing time-of-flight is this vacuum lock chamber. And so that's probably facilitated our switch to AP-MALDI, which was about the same time. So we switched to AP-MALDI because designing lock chamber was a real problem. The other development was, this is like fashion to use FTICR was at that time. So we tried to use permanent magnet to design small FTICR mass analyzer. So this is just picture of prototype of this. We learned a lot about this, and we made some conclusions that why small magnetic field has problems compared to a stronger field from superconducting magnets. But actually, the end of this program was resulted from development of other technology called Orbitrap. Orbitrap actually killed many development in many companies, including this one in MassTech. Actual development of commercial program in MassTech started with participation of the ExaMars project. That was project of European Space Agency where NASA participated as well, and NASA developed a miniature mass analyzer, and MassTech was responsible for designing and building that mass analyzer. So that analyzer is to be used for detection of organic and some biomolecules which could be left after potential life in the past, something. So we built several prototypes there, as you see, and that was a pretty useful effort for us, because people who are familiar with our instrumentation can recognize a lot of electronics we used later in these prototypes, for example. So this is just what start for commercial program. A little later, we introduced our first commercial mass spectrometer called MT Explorer 100. It's hard to call it portable, but we called it field deployable. It means that 69 this is a mistake. It is actually more than 60 kilograms weight. So in general, 60 plus kilograms cannot be carried even by two people. But you can transfer in the field. We used in many commercial programs this analyzer, mostly government programs. We realized problems with this one and immediately started on miniaturization of this. And so this one, MT Explorer 50, we reduced actually mass, power, size virtually twice compared to the first product. Two major improvements were introduced in this instrument. First, we switched to two-section vacuum chamber. That's immediately we eliminated two pumps. So 3 small pumps were included inside. We switched to hydrogen as a buffer gas instead of helium from lecture bottle. So there are no compressed gases used in this. And we tried to, for portable instrumentation, not to use any compressed gases. Even in ion sources, they can be used, but we tried to use, not to use them. So 35 kilograms in this case, 200, 300 watt power to operate that instrument. So this already can be carried by two people without problems. And what is shown here, that hydrostick metal hydride cartridge, which is used as a source of hydrogen. Then we participated in one more government program, and in this case, the goal was to design the smallest GCMS instrument. So our efforts were two-way. First, we made ion trap mass spectrometer as small as possible. At the same time, we tried to use MEMS technology, micro GC as a micro GC in front of this. So that was pretty small instrument. We tried to commercialize it. It was battery powered, that is showed here. Total weight 10 kilograms with battery, size about 10 liters, and very low power required to operate it. But we got into one substantial problem, that fabricating MEMS GC was a real problem, mostly with coating of small channels of silicon wafer channels. So that you should probably make 20, one will work, and each working was not the same. So for this reason, GC component was not, we failed to produce it in commercial scale. So, but this development of miniaturization, we immediately applied to our MT50 to make MT Explorer 30 portable instrument. And that it includes all features. of MT50, the same performance virtually, but we reduced weight twice again, in size twice again. Power no more than 200. It can be battery operated. And performance-wise, it is similar to desktop instrument. As our gold standard LCQ, thermal LCQ was all the time. That's pretty much the same. I would like to acknowledge a lot of people who were involved in this program for about 30 years, which we worked in MassTech and outside co-workers. And thank you very much for your attention. We look forward and develop more in this region, but I'm not going to talk about this. This is too premature.